Hello everyone, I am Varun, Assistant Professor, Department of Mathematics, SJB Institute of Technology.
Hello everyone. Continuing numerical methods. In the previous sessions, we have seen forward and backward difference. Thereafter, we have also seen Lagrange's interpolation. Now, we will look into another very interesting topic. It is Newton divided difference. The formal definition of Newton divided difference is already posted. Now, in this session, we will directly get into one of the problem and look how to construct Newton divided difference table. Okay. So our problem is construct Newton divided difference table for the following table. Okay, x values are given by 7, 8, 9, 10 and the corresponding y values are 3, 1, 1, 9. Okay. So here we can make an observation that the interval is equally spaced. Here I would like to highlight on one more important point. The formulas created for equal intervals cannot be applied for unequal intervals, whereas the formulas of unequal intervals, whether it is Newton divided difference or Lagrange's interpolation, can also be applied for equal interval data set. Okay. So with this, in the construction procedure, the first thing is, of course, the given data is assumed in this way. The first value of x is taken as x0, second value as x1, third value as x2, and the next value as x3. Of course, the last value is also treated as xn few times, very few times in fact, in Newton divided difference. The corresponding value of x0 is taken as y0, for x1 it is y1, for x2 it is y2, and finally for x3 it is y3. Yes. Now, to find the first divided difference column, okay, the logic used here is, of course, we have, as per formulation, we have y1 minus y0 divided by x1 minus x0. So what does it mean? Is like in the numerator I will be having y1 minus y0. In the denominator it will be x1 minus x0. Right? So substituting those, I will be getting 1 minus 3 divided by 8 minus 7. Of course, 1 minus 3 is minus 2, 8 minus 7, the difference is 1. Okay, so the final answer for the first value is minus 2. In the next one, I have y2 minus y1 divided by x2 minus x1. So we can observe here the value of y2 minus y1, x2 minus x1. Right? So I will be having 1 minus 1, of course it's 0. Okay? So in the next stage, I will be having y3 minus y2 divided by x3 minus x2. Yes, analyzing it, y3 is 9 minus y2 is 1, x3 is 10 minus x2 is 9. So we will be having 9 minus 1 divided by 10 minus 9, which is 8. In the previous relations, we usually had just one term, either y1 minus y0 or y2 minus y1 kind of thing in the differences table. Over here, we have y1 minus y0 divided by x1 minus x0 for the first difference. For the second term in the first difference, it is y2 minus y1 divided by x2 minus x1. For the third term in first difference, it is y3 minus y2 divided by x3 minus x2. Is it clear? So the first divided difference terms are minus 2, 0, 8 respectively. Now, coming to the notation part, we already have one small logic in mind that minus 2 is got by, in the denominator term, we had x1 minus x0. So, the first term of first divided difference is usually represented by x naught comma x1 in a square bracket. Okay, x naught comma x1 in square bracket, because in the denominator the difference was taken between x1 and x naught. Clear? So quite obviously the second term, in the denominator term we took difference for x2 and x1, and the representation is x1 comma x2, and for the last term it is x2 comma x3 inside square brackets. Few authors also represent this as f of x naught comma x1. Okay, even if you represent like this, it's nothing wrong, but in our working procedure we will consider it as x naught comma x1 under square bracket. Okay, now keeping this first divided difference column, okay, we will construct the second divided difference, right? So the second divided difference is given by x1 comma x2 minus x naught comma x1. So here x1 comma x2, the value is 0. Okay, x naught comma x1, if you just see the previous notations which we made, okay, from that we can make out that 0 is x1 comma x2 and minus 2 is x naught comma x1. And on the other side, in the denominator I have x2 which is 9 minus x naught which is 7. Getting it? So substituting the values, I am getting 0 minus of minus 2 divided by 9 minus 7. Of course it is x2 minus x naught. So minus into minus turns out to be plus, and in the denominator 9 minus 7 is also 2. So 2 cancels each other, it will be 1. So the second term in second divided difference is given by x2 comma x3 minus x1 comma x2 divided by x3 minus x1. So x2 comma x3 is 8, x1 comma x2 the value is 0, x3 value is 10, and x1 value is 8. So it is 8 minus 0 divided by 10 minus 8. So 8 minus 0 is 8, divided by 10 minus 8 is 2, so the value is 4. Got the idea? These formulas were posted earlier. Now I think making comparison with the formulation, you will get a better clarity. Okay? So minus 2, 0, 8. As you know, it is represented as x naught comma x1, x1 comma x2, x2 comma x3. Now, one observation which everyone has to make here is this one value is got by the difference between 0 and minus 2. Okay, they were in numerator. And in denominator term, I had x naught and x2, and x1 was common in both of them. So keeping that in mind, the first term of second divided difference is represented as x naught comma x1 comma x2 under the square bracket. Getting it? Right? So with the same logic, the second term of second divided difference is represented as x1 comma x2 comma x3 under the square bracket. Right? So with these values, we will proceed further to find the third divided difference. Of course, the formula is x1 comma x2 comma x3 under the square bracket minus x0 comma x1 comma x2 under the square bracket. It means the second term of second divided difference minus first term of second divided difference divided by the difference of x3 minus x0. Okay. So the values are 4 minus 1 divided by 10 minus 7. 4 minus 1 is 3, 10 minus 7 is also 3, so they cancel each other. The value is 1. So our divided difference table, okay, just like our finite difference table, the ending point is either the columns has to converge towards one term or the entire column has to become 0. Okay, here in this case we have seen the columns converging towards one term. Okay, of course the representations. One more interesting observation is like you can make out in the last term we have all the values of x. Agree with that? Starting from x0, x1, x2 and x3. So that is the perfect ending point. Right? Perfect ending point for the divided difference table. So finally, the divided difference table is, yes, minus 208, 1, 4 and 1 being the third divided difference. So this is the procedure, standard procedure to construct Newton divided difference table. It's a very interesting method. Okay, hope you all understood it. That's all for today's session. We will look into few more interesting problems in Newton divided difference in the upcoming sessions. Thank you.